Okay, Assalamu alaikum. So in this video, we'll see how to calculate partial derivatives of a function z, which is defined implicitly as a function of x and y. What does it mean, defined implicitly? It means that we do not have an explicit expression of z. We cannot write z in terms of x and y. Okay, so z is a function of x and y, but the relation between z, x, and y are so complicated that we cannot isolate z. Okay, so how to do this? How to calculate the partial derivative of z with respect to x, for example? So the idea is to derive this equation with respect to x. So what is the derivative with respect to x of this expression? So if we derive x cubed with respect to x, we'll have 3x squared plus y cubed doesn't depend of x, so it's 0, plus z cube. Here, be careful, z is a function of x and y. Okay, so here the derivative of z cube with respect to x is 3 z squared, but times the derivative of z with respect to x. For this term, we have a product. Here we use the product rule. So how to use the product rule? First, we derive with respect to x this term, so 6yz. Then, so as a product of two functions of x, we derive this term, so we'll have 6xy dz over dx equals 0 here. The derivative of 1 is, it's a constant term in terms of x, so it's the derivative of 0. So this is the first step. The second step is to try to collect terms with partial derivative of z with respect to x. So here we have two terms. We make as a common factor, so 3z squared plus 6xy, this term, and move all other terms to the right side. So equals, remove this term, 3x squared, and this term where we don't have partial derivatives. And finally, so dz with respect to x, we divide by this factor, minus 6yz over 3z squared plus 6xy, and this is the formula for the partial derivative of z with respect to x. Okay, here we can simplify a bit. If we make 3 as a common factor, we can simplify, and minus also common factor, we get x squared plus 2yz over z squared plus 2xy, and this is a simplified form of the partial derivative of z with respect to x. Now, if we want to calculate the partial derivative of z with respect to y, so we make the same. So we derive the whole expression, this equation with respect to y, keeping here with the x constant, as we used to do for partial derivative. So the derivative of the first term is 0. The derivative of second term is 3y squared, whereas the derivative of z cube is 3z squared dz with respect to y. And here it's also a product. So it's 6xz, and the derivative of y is 1, plus 6xy, the derivative of z with respect to y equals 0. So we get an equation, and we try to isolate dz with respect to y, the partial derivative of z with respect to y, 3z squared plus 6xy are the coefficients. Here, minus 3y squared minus 6xz, and as we did for the partial derivative with respect to x, we get minus y squared plus 2xz over z squared plus 2xy. This is the expression of the partial derivative of y. This is expected here because x and y play symmetric roles. So by symmetry, the partial derivative of z with respect to x just replace x by y and y by x, and you get the formula, since they are playing symmetric.